Okay, we are going to learn 3.1, which is the chain rule, and it is probably one of the most used derivatives in this course. All right, so the chain rule is actually the derivative of a composite function, but you might not think of this as composition. Okay, so basically you're going to have, up until now, we had the sine of just x, or e to just x, or we had a power rule. But what happens now is we can put a function within a function. So instead of it just being x, we can make it sine of 2x, where this is an inside function and sine is on the outside. Or e to the 4x plus 1. This is kind of the inside and e is the outside. So that's what composition is going to look like in this course. So anytime you have kind of a complicated or more complex looking equation, that's probably your clue that is going to use a chain rule. Now, it sounds really complicated, but this is the formal definition, which you don't ever need to know this, and this one too. So basically, this is kind of what I'm going to explain to you. We have some outside function and some inside function, and your goal is to kind of recognize which functions on the inside and which functions on the outside. So what you're going to notice is when you go to do the derivative, you take the derivative of the outside function first. Derivative of the outside. That's how you start. The inside stays the same. Then you multiply it by the derivative of the inside. And literally, when I taught this class in person, we kind of chanted this as I did the derivative because I say these phrases over and over and over, okay? Once you say it enough with me, then you'll start being able to recognize it on your own. That's the hard part. So like number 1, we've got the quantity x squared plus 1 all cubed. So what you need to recognize is this x squared plus 1, that's going to be considered the inside. And on the outside, it's kind of like it's acting like x cubed. Okay, so that's the outside function. And so we're going to start, when we take our derivative, we start by taking the derivative of the outside function, which is a power rule. All right, so it's not always going to be a power rule. It really depends on what the outside function is. The outside is a power function. So we're going to bring the 3 down. The inside stays the same because that's like our generic x. And we subtract 1. Then I multiply by the derivative of the inside. It doesn't matter that it's to a power. You're going to ignore that now. So we do another power rule. Our inside is going to be 2x. The derivative of 1 goes to 0. And that's it. Clean this up, which the only thing we can do is multiply those terms. So y prime equals 6x and the quantity x squared plus 1 squared. You never reduce or expand a squared quantity. Factored form is the best. All right, so number 2. Well, we can't take the derivatives of square roots, so first we need to change this to its rational power. Square root is the 1/2 power, and so that kind of looks like number 1. So on the inside and then on the outside is another power rule. So when we go to take our derivative, we start with the power rule with that 1/2. So we bring that down. The inside stays the same, and then we subtract 1. Then we're going to multiply by the derivative of the inside, which is another power rule. Clean it up. My 2's cancel, so I'm left with the x's on top, and then this negative power goes back on bottom. Typically, if we start with a root, we end with a root. All right, let's try another one. Well, this one looks a little different. What you're going to notice is we have a fraction, but I have no variable in the top. That's super important. So what we can do is we can actually rewrite this. So I'm going to bring the -7, and I'm going to bring this up with a negative exponent. So 2t minus 3 to the -2. And so this one gets a little tricky. We have a lot going on. On the inside, we've got 2t minus 3. And on the outside, we have this stuff, a power and a number in front that's being multiplied. Well, when you go to do your derivative, if that 7's being multiplied, -7, we just keep it being multiplied. And we're going to start with that power rule. So we get -2 times -7 is +14. The inside stays the same. Subtract 1. Then we multiply by the derivative of the inside only, which is just 2. Got it? Now we're just going to clean up what we can, which is just multiplying the 14 and 2. Now, typically your answers aren't written with a negative exponent, so you might see it like this, especially because the original problem didn't have a negative exponent. This is the best answer. Be flexible. It could be multiple choice. All right, same thing here. I don't really want to do, I can't do anything. So we're going to bring that up. So I'm going to write it as the 1 stays 3x squared plus 4 to the -1. So inside, outside, another power rule. So our derivative, well, we're going to multiply. The inside stays the same, times, subtract 1, almost forgot, times the derivative of the inside, which is a power rule. Clean this up, negative times that, and bring this down since it's a negative exponent. Best answer. All right, and let's do example 5. Now, what you'll notice is example 5 and 6 look very similar, but this is all being squared. Sometimes they're going to try to trick you by writing the original problem like this. These mean the same thing, okay? So they've actually helped you by writing it like that. So inside is trig, the outside is that power. So you're going to start with a power rule. So 2, the inside stays the same, subtract 1. Then the derivative of cosine is negative sine. Well, we can multiply the 2 and the negative. You could put sine or cosine first. It doesn't matter since they're being multiplied. And since I'm right here and I want you to see the difference, let's try this. So now this is the inside, just that 3x squared, and the trig is on the outside. So we're not starting with a power rule. We're going to start with the derivative of the outside, which is cosine. So the derivative of cosine is negative sine. The inside stays the same, and then we're going to multiply it by the derivative of that inside. So the only thing we can do here is put the -6x in front. All right, we're going to stop this video and have you watch part 2.